Welcome to the second session on AWS Machine Learning Engineer Associate exam. Today we will be talking about data ingestion and storage architecture patterns. We all know that data is a very important component in any machine learning lifecycle process. So the next few minutes we'll spend to understand the different types of data, the properties of data that helps us choose the storage pattern. Data can be broadly categorized into three different data types. The first one is the structured, the second is the semi-structured, and the third is the unstructured. Structured data type means it has a proper schema. Consider data in an Excel file, a CSV format, or data stored in a relational database. Semi-structured, meaning it has a flexible structure with some format. Consider a JSON, XML file, or application logs. Unstructured. There's no structure to the data. The raw world of audios, videos, and images would fall under unstructured data type. Having discussed about the types of data, we will spend the next few minutes in having a glimpse of common data formats and their applications. So here we will see on CSV, JSON, Parquet, Avro, and ORC. So these are some of the data format used for ingestion and analytics. CSV is something that we would have used in our day-to-day operations, and it can be used when we have smaller to medium data sets. JSON falls under semi-structured, and the use cases are API responses, log files. It can be used in real-time streaming and application logs. Parquet columnar format, it's a columnar storage, highly compressed and optimized for analytics use cases. Avro is a row-based serialization which stores the schema along with the data and used in places where schema evolution is very much necessary, highly used in Kafka streaming and pipeline serialization. ORC, optimized row columnar, it's very similar to Parquet, but used in applications where we have Hadoop or Spark. Guess. Next, we are going to talk about 3 V's of data. First is the volume. What is the volume? How much is the data that we are going to handle? So if in case we are going to handle enterprise petabytes of data, then it would need distributed storage and parallel processing. So how much data we are going to handle helps us design the storage architecture or the data management solution that we are going to host. So volume is one of the important deciding factor. The next comes the variety. This is a property that we can go back to the discussion on the types of data. So the data that we collect can be of different types: structured, unstructured, semi-structured. So based on that information, we will be able to decide which service or which storage platform that we can utilize for our use case. Velocity, the speed at which we receive the data. Do we need to do a real-time ingestion, or is it okay to batch process it? All that helps us to design the data pipeline that we host. Hope this helps. So the next time when we want to start with understanding a data storage architecture, we will have to analyze what are the different types of data that we are going to handle. How much is the data that we want to store? What is the velocity at which we will receive the data? With that, let's go to the next section on the different data management solutions. What is a data management solution? So we know that data is a very important aspect of any machine learning lifecycle process, and we will be receiving data from different streams. Like the data that we get for a machine learning lifecycle can be from a database backend or from an API endpoint, from streams or messages or batch files. It can be any one of these. So, as I said, the data can be of different types, the volume can be different, the velocity at which we receive it can be different. We will have to handle the data effectively so that it can be utilized by the downstream systems. Like we will have to get the data, store the data, analyze the data, make it in a format that can be consumed by the downstream systems to help in the machine learning process, like training the model, evaluating the model, and deploying the model. So all these has to happen seamlessly and automatically. Then we will have to have a data pipeline and the data management solution. So the success of our machine learning is highly related to how we manage the data. Data warehouse is one of the data management solutions that aggregates data from disparate data sources like databases, business applications, and social media feeds into a single store. This uses a approach called schema on write, meaning while it writes the data into the storage solution, it applies a consistent schema to the data. As it follows the structured schema, it is highly useful in business analytics and intelligence. A common data warehouse architecture can be thought of as three layers. The bottom layer, meaning aggregating the data and loading it into the storage. The some middle layer being an online analytic processing engine that helps us to query the database layer. And the third or the top layer would be the UI that is presented to the users or any downstream systems to visualize and fetch data. The AWS service that falls into data warehousing is Amazon Redshift. As the data warehousing follows a structured schema, it is not greatly useful for exploratory data analysis and raw data formatting. The next is the data lake. Data lake is a low-cost storage solution for massive volumes of data. It is flexible. It has an approach called schema on read, meaning while we ingest the data, there is no schema that is required. It can handle structured, semi-structured, and unstructured data. But while we fetch data using any analytics tool or UI, we have schema enforced. Data lakes are mostly cloud object storage solutions. In AWS, it is simple object storage, which is S3. As it is able to handle flexible data types, it's greatly useful in hosting large data sets that are used for model training and exploratory data analysis. The next is data lakehouse. So we have seen two data management solutions. The first one was the data warehouse, and the second one is the data lake. Data lake house is a combination of core features of data lake and data warehouse, meaning data lake house patterns can handle different types of data like flexible data types, structured, semi-structured, and unstructured, and as well provides the capability of fetching data with a proper schema. So it follows both schema on read and schema on write. So Amazon Redshift Spectrum is one of the examples of data lakehouse patterns in AWS, which is used to query S3 data with warehouse performance. So this makes it useful for machine learning exploration and historical analytics. Here is a quick glimpse of differences of the three different data management solutions that we have discussed: data warehouses, data lakes, data lake houses. So data warehouses are for structured, lakes and lake houses of flexible data. Relational databases could come under data warehouse tooling. Data mesh is an architectural framework that provides decentralized and distributed domain ownership. Why do we need data mesh? Instead of having a central team managing all the data and how it is consumed and handled, data mesh architecture helps with four pillars of handling data in a better way. The first one is the domain ownership. Each of the business domain is given the responsibility of handling its data and APIs. Data is treated as a product. It has its own SLAs, quality standards, documentation, and discoverability. The third pillar is the self-service infrastructure. There are shared platform and tools provided that enables teams to build and publish data independently. Though there is ownership and independence provided, we have federated governance, standard policies, and that the team has to follow to ensure compliance. When do we use data mesh architecture? When we have 50 plus data teams and rapid data product developments. So far, we have discussed on the different types of data, the properties of data, the data management solutions, data mesh architecture. So having discussed all of that, the next thing that we are going to talk about is the ETL pipeline and why do we need them? We need a way to have the data from variety of sources collected, transformed into a usable format, and loaded into a storage solution from where it can be consumed by our machine learning pipelines. Right? So that is where this ETL pipeline comes into picture. The first E stands for extract, meaning we are retrieving the data from data sources and then transform. This is where we clean, validate, enrich the data. Feature engineering happens in this stage of the ETL pipeline. And once we have the data, it is loaded into a data warehouse, lake, or a lake house based on the use cases. So there are different orchestration services provided by AWS for ETL. Some of them are Glue, step functions, managed workflows for Apache Airflow, and data pipeline. Here is a simple representation of the ETL pipeline where we have the data from different data sources flow into this step functions where ETL and feature engineering happens, and then it is being consumed by the machine learning workloads.
Hi everyone. So let's understand about S3 storage. S3 storage is one of the important services what an ML engineer needs to understand. So AWS provides S3 for storing the objects. The object size can be up to 5 TB. If your object size is more than 5 GB, then multipart upload will be used to upload the object to the S3 bucket. S3 storage is one of the most scalable storage and it is cost effective as well. So based on your use cases, the objects can be moved to various storage classes as well. And based on your latencies, you can plan the S3 bucket to be created on those regions. So let's understand about how to create an S3 bucket. How can you add a bucket policy to S3 and also understand about versioning. So I'm going to create a S3 bucket, basically a general purpose bucket. So I'll click on create bucket. Once I click on create bucket, there are two types of bucket type. One is a general purpose, the other one is a directory bucket. I will be creating a general purpose bucket. So my bucket name is demo data ops ml bucket. Okay. So I've created a bucket and here I will uncheck block all the public access. So we'll understand how to create a bucket policy once we create a bucket. So I'll just acknowledge this and say create bucket. So once this bucket is created, we will be adding permissions to this bucket. So the bucket is created. I'm clicking on permission. So click edit. So let's add the bucket policy. The statement is, so the service for which I need to give permission is S3. So for the purpose of this demo, I'm choosing all actions, and on the resources, I need to give the S3 bucket. So I'm just copying this and add resources. I'll just say bucket and then choose. So I'll just say all the objects and say add resources. And here anybody should be able to access this bucket. So I'm changing the principal to star. So now that I have created a bucket policy and I have saved the bucket policy as well. So the bucket policy is successfully added to this bucket. So let's try to upload an object and understand how the bucket policy works. So I'm uploading index.html. I will also upload an other cat pic. Okay, so I have uploaded two files. So the upload is completed. Now let's click on this object and try to understand the bucket policy. So basically we'll be able to do all the operations on this bucket. So I'm copying the object URL and pasting this object URL here. So basically we should be able to access this page. So I'm able to access this page. So let's check with the other object. So I'm copying the object URL and I'm just trying to access it. So I'm able to access. So this is the object which I uploaded. So I'm able to access the bucket. So this is about the S3 bucket policy. So let's understand about versioning. So I have a bucket called as demo data ops ML bucket. So here I need to enable versioning. So you can go to permissions. In permissions, you can go to properties and click on edit and enable the bucket versioning. Okay, so now that I have enabled bucket versioning, I'll go to objects. I will upload a same object. So I'll upload cat one more time. Okay, I'll close this. I'll try to upload add files. So I'll try to upload index.html one more time. So I've uploaded. So basically we have uploaded multiple files. So let's check. So this is the bucket what I created. So I have enabled versioning. So to check the versions, you have to enable this. So I have uploaded here. So basically what happens is, in case I am closing this and I am going to delete this cute cat picture. So just type delete. So if you're typing delete, okay, so close this. So now you're not able to see cute cat picture, but you had uploaded it twice. So now when I enable version, you're able to see the cutecat.jpg is not deleted, rather than a delete marker is added. So in order to delete this permanently, you need to select this and click on delete, and once you get an option called as permanently delete, you will not be able to find that object again. Else, that if you have another version, that object will be pointing to the latest version. So now that I have deleted this, let's check. Okay, so it's not there here. Okay, a null has been added here, and now if I delete this, this should permanently delete the object. I had uploaded two versions. First time when I delete marker was added. Second time when I delete, it should not be here. So now it is only the delete marker, and it is of size 0 size. If you're able to, if you're trying to access this, you'll not be able to access it. So this is how versioning works. So this is my source bucket. I will be creating a replication. I'll go to management, and in the replication rules, I'll say create replication. For creating replication, and this is my rule 1, and choose whether the rule should be enabled or disabled. So it should be enabled. This is the source bucket. So I'm just leaving this as it is, and my destination bucket, browse here to the destination bucket. So yeah, I wanted my destination bucket from US West to so I'll just select here and choose the bucket. Okay, so you have chosen the bucket. You will be creating a new IAM role for this replication. So additionally, I'll also check for the delete markers so they can be replaced. So I'll just say save. Okay, prefix I'll apply to all the objects, and I'll click on save. Okay, so yes, replicate the existing objects. Okay, so I have specified to replicate the existing object. So this replication rules is created. Now what we can do is we can go to DataOps ML bucket, try to upload one file. So I'll just try to upload cat. So qt.jpg. So I've uploaded it. So once I have uploaded it, I will go to my replication bucket in Oregon. So this is my replication bucket. So you're still not seeing the objects. You should be able to see that. Okay, so this object is appearing now. So that's it about replication rules. Hi everyone, like I already said, we'll be talking about S3 storage classes. So based on your use cases, you will be choosing the storage classes. So the different storage classes, what is available is S3 standard. S3 standard is one of the common storage classes which we will be using. So for frequently used data, we'll be using S3 standard. S3 intelligent tiering, in case if you're not aware about your access patterns for the data, then you can choose S3 intelligent tiering. If you are not accessing the data very frequently, but once accessed, you need a rapid retrieval, then you can choose S3 standard infrequent access. The difference between S3 access infrequent access and S3 one zone infrequent access is your data will be available in a single AZ for one zone infrequent access. So if the data is lost, you cannot retrieve the data. So in that case, you might not choose one zone infrequent access. We also have glacier flexible retrieval and glacier instant retrieval. So for long term and occasional access, you will be going for a flexible retrieval glacier. For accessing the data immediately, but long time archive required, then we will be using Glacier Instant Archive Retrieval. For long term storage, we will be using Deep Dive Archive. And if you wanted to do any kind of processing the data locally, then we'll be using S3 Outpost. So let's take a look at S3 lifecycle transitions. So in order to reduce the cost, we will be moving the objects between the storage classes. So while moving the objects between the storage classes, we will be able to bring down the cost. So you have a use case that you will be storing an object in the S3 standard for 30 days, and then you might not be using that object of accessing it frequently after 30 days. In that case, you can transition that object to an infrequent access. So you have S3 infrequent access. In case you will not be accessing this um, but wanted to archive this, then you will be moving that to a different classes. So based on the lifecycle rules created, the objects will get transitioned to various storage classes. So let's see the demo about this. So we have an S3 bucket. We have an S3 bucket called as demo data ops ML bucket. So the demo data ops ML bucket has two folders. One is the HTML folders, the other one is a picture folder. So in HTML folder, I have an object, and even in the picture folder, I have an object. So let's try to create a lifecycle rule. So I'll go to management. So in management, you have lifecycle configuration. So we will specify a rule for that. So let's create one rule for this. So I'll say rule 1. Rule 1, I will not be applying to all the objects. I'll be limiting the scope based on the filters. So like I have HTML tag, I will be creating this for the HTML folders. So what I will be doing is permanently delete. I'll just say transition the current object between the storage classes, and I am acknowledging this life cycle. Okay. So from infrequent access, it had the days after the object creation. So after 30 days of the object created, the object will get transitioned to infrequent storage. Then to instead of intelligent tiering, I'm just using a deep dive archive. So after 90 days, I will be pushing this to deep dive archive, where I will not be using it for frequent access, but I will be accessing once in a while. And I will say create rule. So I've created one rule. So let's try to create another rule. Okay. So I will say rule number 2, and this rule is applies for all the objects which are under the picture folder. So I will be here, I will try delete the expired delete markers or incomplete multi-part uploads. So this will bring down your cost, and also expire the current. Okay, I will delete the non-current objects. Okay. So here the number of days for deleting the non-current object, I'll specify it has 30 days. Okay. And number of versions it has to delete, I'll just say 2 versions. And you will say create rule. Okay. So by default, object less than will not get transitioned across any storage classes. So your objects which are less than 128 KB, they will not be moved across any storage classes. So just confirm this. So right now you have two rules enabled, right? So now you can go to this, select management. You have one lifecycle rule and one replication rule. So both of these rules you have created. So the objects will get transition as per the use case you have selected for. So we saw the demo with the lifecycle rules transitioning to various storage classes based on your use cases. So we can take a look at S3 notifications, how S3 notification works to automate workflows. In future, we will be seeing how we can use S3 notifications to automate ML workflows. So let's go to the demo. So I will be creating a S3 bucket. So the S3 bucket name is going to be my demo bucket 2023. Okay. So for now, I'm just unchecking, blocking all public access, and I'm just creating a bucket. So this bucket name is already been taken. So we'll just add it as 2027. Okay. So I've created this bucket. So once this bucket is created, we'll go to Lambda function. We'll say create Lambda function, and name of the function we'll give it as S3 upload. So I am choosing Python version 3.12, and rest I'm just leaving it. Okay. So I wanted my Python code to be triggered whenever there is an S3 upload happening. So what I will be doing is I will upload the code here. Okay. So I've just uploaded the code here. So once it is uploaded, I'll just save this. Okay. So now I'll go to trigger. So in trigger, what I'll be selecting the source. My source is S3. So I've selected S3. So which is the bucket? This is my bucket. And what kind of events? So I'm selecting all object create events. Any object, it has to trigger. So I'll acknowledge this and I will add this. So basically I've added the trigger. So I'll go to my S3 bucket. So here I'll just try to upload an object. So when I upload this object, the S3 event has to go and trigger the Lambda function. So let's try to see if it is triggering. So right now I'm uploading it. So if I go to the Lambda function, this is my Lambda function. So my Lambda function is here. So click on this. So the object is completely uploaded, so it is succeeded. So I'll just close this. I'm going to S3. It just takes few seconds for the notifications to be reflected. To check whether it has triggered the Lambda function, you can go to monitor, and in monitor you can check the count. The count is 1, so it has triggered the Lambda function. Thank you all. So today we studied about S3 and a few of the functions of S3 like lifecycle rules, S3 notification, bucket policy, uh, S3 bucket replication as well. So thank you.
Hey all, this is Chandika. Let's continue where Ranjini left. So I will be talking about S3 encryption and access control mechanisms. Hope my screen is visible. So starting with server-side encryption, Amazon S3 supports multiple encryption options to protect data at rest. You have two options in encryption: data at rest encryption, data in transit encryption. So we are talking about data at rest encryption. So when it comes to data in transit, you will learn about SSL TLS certificates. So let's see the options available. Server-side encryption, S3 managed keys. In this option, AWS handles key generation, storage, rotation automatically, making it simple and easy to use. You don't have the management burden of the keys and the rotation, everything. This is very simple and powerful, but you will not have the access logs, CloudTrail logs on this. SSE KMS is server-side encryption using Amazon Key Management Service. Here, you control the encryption keys, define access policies, get audit visibility through CloudTrail. This option is preferred when compliance, auditing, fine-grained access control is required. Next comes DSSE KMS or dual layer server-side encryption with KMS. Encrypts key encrypts data twice using two separate KMS keys. It is designed for highly regulated environments that require additional layer of cryptographic protection. Together, these options allow you to choose the right balance between simplicity, control, and compliance. Let's talk about access control mechanism. Before that, I will show a short demo on how encryption can be enabled. Let's see a short demo on how encryption can be enabled. So in the S3 console, you will go to create bucket to create a new bucket. So encryption can be enabled when the bucket is created. So you will give the name of the bucket, then come down. You can see the encryption option available. All the three which I have mentioned. So the first option, when you select this option, S3 itself will create a key and it will manage the key. But here, when it comes to AWS KMS key encryption, then you need to create a key for the first time. If you have already, then you can mention the ARN of the key. Same for dual layer server-side encryption because both option uses AWS KMS keys. And let's see the access control mechanism. So you have IAM policies. IAM policies are attached generally to users and roles. Through IAM policy, you can manage or control accesses to users and roles. Then comes bucket policies. Bucket policies are resource level access rules for this specific bucket. Block public access. So when you create a bucket, this option is enabled by default, which means all the objects within this bucket are not publicly accessible. So this gives you minimum guarantee of blocking public access for your objects. Let's see how IAM policies, bucket policies works. So I have a bucket created like this. Let's go to IAM console. So I'm going to policies. Create a policy. Here you can use options like this. Select the actions. So for now, I want to give get objects so users can just view the content of my bucket, then give the resource the specific bucket, then go next. Your policy will be auto-generated. But for now, what I'm doing is I'm going with this option policy editor because I have the policy already in hand. If you see the structure of IAM policy, you have this version. This is a mandatory one. then you have statements, which is not mandatory, but sorry, I'm sorry. So statement is mandatory. Within statements, you will have three parameters called year, effect, actions, resource. So you will mention what effect this policy should have on this action, on this resource. So basically, I'm allowing to list the bucket on this bucket. I'm allowing to get the objects and put objects on this bucket, and I am explicitly denying not to delete the objects in this bucket. So yeah, going next, I'm just giving a name for this policy. So yeah, create policy. So with this, we created the rules uh, for this for a particular user. So let's attach this user. Let's attach this policy to a user. I have this username called Chandika. So I am going to add permission. Go to add permission. So we will attach the policy directly. You can see the policy which I created just before. Go next, add permissions. Yeah. So like this, I have added permission. So this user, Chandika, will be able to get the objects of this bucket, download the objects, but not delete the objects. Here is how you can control access for a bucket for a particular user. Like this only, you will attach the policy to roles also. Let's see the bucket policy. So I created this bucket. I will go to permissions. Here you can give a bucket policy. So what I'm doing is I'm giving a rule that no one can delete objects in this bucket. What I'm doing is, so I have a policy already in hand. So see, if you see version statement, under statement, you have the year parameters, effect, action, resource, which is the same we saw in IAM policy. Only one extra parameter is available, which is principal for bucket policy. So what I'm telling is, I am doing one explicit deny for all the objects within this bucket. Here the bucket name is this one. I'm just changing the ARN. Like this. Save changes. So with this bucket policy, no user can delete objects from this bucket. Then comes performance and optimization for data ingestion. When working with large-scale data ingestion into Amazon S3, performance optimization is critical to maximize throughput and reduce latency. First, prefix parallelism helps increase upload and list performance. By spreading objects across multiple prefixes, S3 can handle many requests in parallel instead of bottlenecking on a single prefix. Next, multi-part upload is used for large objects. The file is split into smaller parts that are uploaded simultaneously. If a transfer fails, only the failed parts are retried, making uploads faster and more reliable. Then, range gets allow you to download specific byte ranges of an object. This enables multiple parts of a large object to be fetched in parallel, which is especially useful for analytics and machine learning workloads. Finally, S3 transfer acceleration reduces latency for long distance data transfers. Data is routed through AWS edge locations and global AWS network, significantly improving upload and download speeds for geographically distributed users. Now, let's talk about S3 cost management and how to optimize storage and operations without sacrificing access or performance. First lever is storage class pricing. Choosing the right storage tier has the big impact on cost. Use S3 standard for frequently accessed data, intelligent tiering when access patterns are unpredictable, glacier classes for archival data that is rarely accessed. Next are request cost. S3 charges for operations like put, get, and list. Frequent small requests can quietly increase your bill, so it's best to batch operations whenever possible. The third factor is data transfer cost. To reduce egress cost, keep compute and storage in the same AWS region. Using VPC endpoints instead of public internet access also helps lower data transfer cost. Another powerful optimization is lifecycle automation. Lifecycle policies automatically move cold data to cheaper storage tiers and delete data that is no longer needed, preventing long term storage waste. Finally, avoid the small file explosion problem. Large number of tiny objects increase request cost and reduce performance. Combine small files into larger archives. Use larger multi-part uploads for better efficiency. By combining the right storage classes, smart request patterns, automated lifecycle rules, you can significantly reduce S3 cost while maintaining reliability and performance. Let's see machine learning use cases of S3. So, all the raw data, curated training data, versioned data, everything for the large trainings data sets are stored in S3. Feature storage. All the featured data are stored. And then training inputs, outputs, the metadata of the models, version history, everything are stored in machine are stored in S3. After the model is live, all the logs, metrics related experiment traces, all the monitoring data in short are stored in S3.